to Transformation in Trials. Welcome to Transformation in Trials. This is a podcast exploring all things transformational in clinical trials. Nothing is off limits on the show, and we will have guests from the whole spectrum of the clinical trials community. And we're your hosts, Ivana and Sam. Welcome to another episode of Transformation in Trials. Today in the studio with me, I have Marilee Lloyd, who is a laboratory planning leader and an architect. Hi, Merilee.
Hi there. Good to be here.
I'm so excited about this conversation. Today, we're going to be diving deeper into designing laboratory spaces. This is a topic we have not had on the show before, but as we recently heard from a different episode, it is actually very important and can be a competitive advantage. So, Merilee, just to set the stage for our listeners, can you tell us more about the different steps that you would go through to plan a new research lab?
Sure. That's sort of a big, long thing that we do. And, depending on the size of the lab, it can take a long time. But it starts with conversations, as you might expect, and setting the stage and understanding what the problems are and what the strategic goals are for the lab. What do you want to do with your lab? What kind of science? So we talk about that, and then we tune it to what the science is, or what the discovery process is, how robotic it might be or not, what the instrumentation is. We try to do this very modularly, so it has a very flexible and adaptable kind of approach, so that as the lab changes, because they change, it can grow and new instruments can be added. So we talk a lot about how that should be, how flexible it should be, and how much wet space is needed, how much dry space is needed, how much computational space is needed. We're finding now that more and more space should be computational space. So dry, but clean. So all of those conversations go on, and we get a basic idea of what it should look like. And slowly but surely, through a series of design meetings, we work through the different areas of the lab, how they all work together, what areas, how many rooms there should be, how those rooms should fit together, what the flow of the research should be. And we design all that. As a laboratory planner, I partner with our mechanical, electrical engineers, our structural engineers to understand how their systems should be brought into the lab, what the lighting should be like, what the HVAC systems need to do. So they are experts in their thing, and I work with them. They are part of the design process. I also work with I am an architect, but I also work with our architecture folks for the overall design of whatever building the lab is in. So I will talk with them about collaboration spaces or other amenity spaces and how those get engaged into the laboratory, and how in some cases we can use that flexible space, that collaborative space, as flex space, or how we use the office space as flex space or dry space as flex space, so the lab can change and grow. So lots of conversations. We go through this process, develop it in our Revit model, which is our electronic model for how we deliver our drawings. We draw in that model and produce those drawings, work with a contractor to get it built. So that's really briefly the process. Lots of different partners and players. We try to engage our client and user groups right the way through, because they're the experts in their experience. We're the experts in what we do, but we need to understand their science.
Mm. And when would you typically start getting involved when someone is thinking of building a new lab?
The sooner the better, honestly, so that we can work with them to understand the goals for the space. Because sometimes, we get folks who come and say, this is the problem with my current space. But when we start asking questions, the surface problem isn't the real problem. The thing we need to solve is about 6 layers down. And so They may say, well, I can't do this thing. And maybe ultimately what we find out is that the services aren't flexible enough. And so what we need to do is, provide a more flexible and adaptable laboratory that allows them to change and grow over time. They can't, for instance, maybe get a new instruments because maybe it doesn't fit through the doorway. How do we, even basic things like that, how do we solve their problems? So that's sort of, we start with those conversations.
Oh, I see. I am curious about this idea that labs can change and that they can be adaptable. Because in my mind, a lab is something you build and it kind of is pretty static there. You like bolt stuff to the floors and then it just remains the same for a very long time. Tell me more about how flexible can a lab be?
Well, we make them pretty modular, and most planners work with a module, and the module can vary. The size of that module can vary based on the kind of science that you're doing, but typically, most generically, we'll use an 11 by 11 foot module and plan the lab along that module and put the benching along that module line. So that gives you space on each side. It also gives you space if you want to have a fume hood in one place, or if by using flexible mobile benching systems, you can pull out a section of benching, put a piece of equipment in, and because your services come in from above, or sometimes through a service chase between the different benches, depending on the system you're using, you can make that more flexible and adaptable over time. It's easy to stop it, put a piece in, remove shelves, for instance, on the flexible system. So you can put a bigger piece of instrument on the bench. And because you're planning some of your services, you can plan that in a carrier or a module of sorts so that different services, pipe services, can be brought in more readily, so things can be changed out. Even if it means putting in more piping, at least you've got a regularized process for doing it. So it becomes more flexible, and it even can be constructed off-site and then put in. So your building site isn't taking up the space with that, and it's kept clean in a factory and not potentially getting dust in it on site. So lots of different strategies.
No, I like the idea of that a lab it's not a room. It's actually a lot of components, subcomponents in that room that can in fact be flexible and exchangeable.
Right. And different lab areas need different things. You've got some spaces where it's open benching, and so you want to bring in daylight into that space, but you've got other spaces where you don't want the research doesn't need to see daylight. In fact, it should not see natural light or light at all. You need to make it dark. So being able to have that flexibility, have spaces that do one thing, spaces that do another thing, and be able to use them appropriately is part of what we like to plan for and talk about during the design process. How much of that space do you need, and how much of it is going to be computational space? Because there's a lot of clinical instrumentation now that is just a clinical line, and it has a whole lot of needs. Sometimes it sits on raised flooring, sometimes not. Sometimes the services come in from above. Both strategies can work. There are a lot of different service or pneumatic connections that need to go on, but maybe it doesn't need, it needs to be a little bit more flexible, but it's not going to be the same sort of thing as a research laboratory. Maybe it's just computational space. Maybe it's not clean, as clean. So lots of ways to make that flexible and adaptable for the future.
That makes sense. I'm also curious about this computational space thing. I had a recent example where there was a lab where I was talking to one of the lab technicians that said that they were struggling with digitizing their processes because there were no computers in their labs. So what would happen is that when they did experiments, they would keep a notebook, and then no one wanted to enter the notes from the notebook into a computer afterwards. And I'm just realizing now, well, this may actually be a lab design problem and not so much a digitization problem.
Right. I mean, we're seeing a lot of spaces where there is a lot of instruments have a laptop or other computer adjacent to the piece of equipment. And so information can be culled there. And also, there is so much data connected to the cloud now that data from some instruments can be collected in the cloud and brought down to a tablet. So we're seeing that level of digitization so that results are downloaded to a tablet, and that tablet can be removed from its dock, taken out to another space, and then downloaded and manipulated into a report. So that sort of system can work, or someone could stand with a tablet, write their results. It can be, there are plenty of programs now that will take handwritten notes, digitize them, and then that can go into the report. And it instead of having that paper product, it's actually cleaner in the lab. So you've got that more simplified, so you can just shoot it off to your laptop back out in your write-up space at your desk and go back there. So you don't have to have that. The lab notebook is digital. Yeah.
That makes a lot of sense. And also that is the promise of tablets, that they would transform that space. And here we actually have the opportunity. But there are also issues of older labs having older instruments that may not be able to output even almost digital data.
Right.
I've seen strips in labs still being outputted. How do you modernize an older lab?
That is a very carefully planned dance. Because you sometimes cannot take some of these instruments offline. They're critical systems. For instance, at a clinical lab in a hospital, you just can't take some of that stuff offline, not easily. So you are either building a redundant system inside, so you have parallel system, and then switching, and then going back and fully renovating the space. And that's one of the things that is useful about having that flexible space, is because if you've got a space that's set up to be adaptable and flexible, you can perhaps more readily create that parallel system and then go back and renovate. But it is a carefully planned space dance, because that space is super expensive, and so we have to be surgical and clear about what we're doing.
Yeah, I could imagine. And are there ways that you've seen that if you design your lab well, that it can actually help the company achieve its clinical outcomes, or whatever the lab is doing, really help them drive towards the outcomes that they're trying to achieve?
Absolutely. The idea is to, with both clinical and more absolutely recently, CGMP space, we talk about spaghetti diagrams, right? And so we use those diagrams and have a meeting with our user groups to sort of diagram out how they are using their lab. And we'll look at the existing space and they'll diagram, and it's, all over the place. And then we'll try to plan a space that organizes those flows and organizes both the movement of people and how they need to work, and the movement of their materials and how those need to come in, and any samples and how those need to come in. And so we can start to achieve efficiencies by planning all of that and not letting it just sort of grow by accretion. Because sometimes labs were in the past sort of very, very hard-walled, different cells, right, of things. And now, because of the way of some instrumentation works, you don't really need those very cellular environments. You can have a more open environment because a lot of the enclosure for the instrument itself keeps that sample safe, right? So, or you can design the lab so that the pressures are such that it keeps the samples safe. So, like in an instrumentation or an analytical lab, the GCs can all be grouped, and there you can find efficiencies in how you design that flow.
Are there any similarities between what you're trying to do in the lab and a good lab design, or is it more specific to the way the company also works, how the employees interact with each other? Like, is there a package you can deploy and say, oh, this would be a nice biotech lab?
A lot of it does depend on the culture of the different companies. And most companies are now looking to have a more inclusive and diverse population. And so there are strategies we use to try to implement that. One size does not always fit all. So we try to understand the goals for our clients so we can develop the right strategy, and so they get the results they need. So goals, strategies, results. But that said, what we're trying, there are strategies we use. The way the collaboration space works adjacent and where the offices are, all that is a part of the culture and how they may or may not want people to interact. And different groups that they want to bring together. And by making the space flexible, they may be able to change that over time and reorganize so that different groups are together for different projects or products. So we do talk a lot about those sorts of allied spaces, like collaboration spaces or meeting spaces outside the lab, because there are important meetings that can occur between lab teams that we want to facilitate. And even simple choices like having a material corridor to bring materials to a series of laboratories, connecting them all, allows for a certain level of interaction between scientists as the materials are moving in and out. So you get that interaction, or finding those shared instruments that can be brought to a space and create a shared instrumentation core, so that then you get a certain collaborative spirit, and that speaks to the culture that you want to create in the building.
I think that's fascinating. That's the way that it impacts both ways. It starts with, well, how are people with each other already? And then you design the lab for it, but also the way that you design the lab impacts, well, how are the people with each other?
Yeah, it's the chicken or the egg question, right?
That it must also be interesting to visit a lab and see if, based on how the lab is designed, you can predict something about, well, how do people work with each other here? Are people very separate and individualistic, or is there a lot of collaboration happening?
Right. So it's more and more frequently, for instance, we want to have glass a view into laboratory spaces, except when, we want to, there are moments where you want to control the view, either for IP issues, intellectual property issues, or because the space has to be dark. But for touring people through a lab, you maybe want to show them rather than take them inside and have them have to gown up or potentially dirty a space. So having those controlled views are important. It's also important for safety. So someone can look in and see that everything is operating appropriately and people are safe in the lab space.
No, that makes sense.
So,
who would be the proper kinds of people to involve in the design of a lab? Because it's not only the people working in the lab, I assume.
it is not. We usually talk to both the lab users and the facilities group. So the people who run the building, who are going to maintain the HVAC system and the lights so that we design that appropriately. Sometimes organizations have building standards for how they want to, have a particular kind of light or light fixture so they can stock it and have it ready, and so they know what kind of fixture to get. And if they've got multiple sites across the country, they may want a specific fixture. So, or within a certain group of fixtures. So, or a certain kind of flooring, or they may have. So we have to pay attention to the standards. So we'll talk to those folks. We talk to the safety folks to make sure that the chemicals that we're bringing in are what they want. So we understand what the quantity of those chemicals are, because we'll also talk to code officials in the city or jurisdiction that we're working to make sure that we're conforming to all the requirements that the code has for us, in terms of how the building works, how the building is built, and how any hazardous materials, because labs often have some hazardous materials coming in and out, and how we're dealing with those is crucial. We sometimes are asked to do flow studies of how the air from fume hoods or other things are ejected into the atmosphere, so we can prove that we're doing that safely and not pulling it back into an adjacent building, or that we are ejecting it right. So all sorts of different people, and the design team, we've got all sorts of different mechanical engineers, electrical engineers, architects, landscape architects, interior designers, all sorts of people on our team. So they all need to talk to different people. It's a very complex dance to do a large building.
That does indeed sound complex. Merilee, I'm curious to learn more about how did you end up in the lab design space?
When I was deciding on architecture school, or if I wanted to be an architect when I grew up, I also was interested in genetics and science. And I really, really enjoyed those classes in high school. And so I thought, well, what do I want to do here? So I apprenticed or worked for an architect for a summer and thought that was great fun. And then decided on architecture school, went to architecture school, and then had the opportunity to design a laboratory early on in my career. I had done a little bit of commercial space, and we were doing a high school, and I got to do a science lab, and that was spectacularly fun. And then I had the opportunity to do an even more intense science laboratory. And, so it was, then this can balance my interest in science and my interest in architecture. And so more and more, I just gravitated, and I've been in practice for 38 or so years, and I've been doing lab design for a good bit of that, most of that. So it balances those interests. And for me also, it's almost a right brain, left brain kind of thing, because you have to be creative, and there's always something to learn, something to challenge you. But designing these buildings is very rigorous too. So it is really a very interesting and deep career.
I find it interesting that somehow when you have more constraints, you can get smarter and better choices and better design than if you have all the freedom in the world.
Yeah, I think a challenge, a challenge can be a great thing.
Mm.
It is sort of what you get up in the morning for.
Yeah, absolutely. One of the things we talked about during the pre-call that I have been thinking a lot about since is the notion of designing labs for sustainability and inclusion.
Mm-hmm.
Can you tell us a little bit more about, well, what goes into that? How can you make a lab space more sustainable and inclusive?
Labs have been, I don't know, forever thought of as energy hogs, but there are a lot of things we can do to reduce that. And it starts with thinking about how many air changes you really need. And what are you going to do when no one's in the lab? Can we dial that HVAC system back a little bit when no one's in the lab? And how about those fume hoods? Can we go with a high performance fume hood that maybe doesn't need the same face velocity that can still achieve containment very safely at a lower face velocity? Can we have a sash closer that closes the sash and then thereby reduces the air flow and saves energy? And the energy savings from those kinds of hoods has been increasing. And so the payback period has gotten shorter. So they are far more viable than they used to. We've also got more choices in terms of flooring materials that are a little more sustainable. Companies are getting better at making wood products like wood casework and steel casework that is recyclable or from a renewable forest. So we focus on a lot of things like that. We focus on resiliency and, how do we do standby generation? What needs to be backed up? Can we use PV systems to help power the building? How do we use things like rainwater or to use as water? Can we purify that rainwater and use it in the building? So lots of strategies for, can we do a green roof? Can we, in terms of the culture, there's also bringing in natural light and using biophilia, which is biophilic elements, things that mimic nature, in order to make the space feel better to be in. Can we key our LED lights to mimic sun patterns so that you feel like you've been, not in a fluorescently lit shoebox for, 12 hours. All sorts of things like that. So there are multiple strategies, and we talk a lot about how to do that. And in terms of inclusion and diversity, those conversations, universities are super into this, as are a lot of companies, and we talk about providing ancillary spaces for people who need a moment during the day for prayer, need a moment for nursing, just flat out need a moment, because we've all had those days. So, to give a neurodivergent person a place to chill for a moment is important. So understanding those sorts of things, using lighting or being able to key the type of lighting so that it doesn't trigger someone with migraines. Fluorescent lighting is horrible for that in its flicker. So it is all of those things help to create the culture. Some of it is, embedded in helping the experience of the building help people make a shift and think about things differently, and bring in people. Can we provide? Can we help the client site the building near a? If we're talking to them early on in the process and they're still looking at sites, can we put the building on a bus line or a rail line so that people can get to it who might not have a vehicle? All those sorts of things are, part of that design process and conversation that, if nothing else, they can set off a little thing in the back of somebody's head that makes them think, oh yeah, we need to do this thing because this will bring more people of diverse backgrounds into our building, and that will make our science better.
I love how it all starts with the very small practical things like being near public transport, which does make a difference if you're a young person, if you're from a tough financial background, something like that, and how that leads to more diversity. I love that it's like the cold storage chain starts pretty early on. Is where is this building?
Yes, yeah, it's that same sort of conversation.
No,
and
I love
talking those things through, and that's why a lot of innovation centers or startups are near universities, because there's usually a student body to draw new people from. And often a university town will have some sort of bus system, or it'll be large enough to have a rail system, so there'll be support for them to be able to get to there, or bike paths, providing a bike storage location, a place for a shower. All of those little things that we do for sustainability reasons too are also about diversity and inclusion.
That's interesting, and how they both relate and how they impact your science, as you said.
They do. I mean, I think we know that for years and years and years in the past, a lot of experiments were designed for primarily men and white males. And now there is a lot of focus, I'm being told, on broadening that research spectrum and making sure that in clinical trials, you're reaching a broad range of people. The same is true in the lab. In order to be able to better understand that you need to reach out, it's useful to bring in those diverse peoples.
Exactly. That's super interesting. Well, Merilee, as we start rounding off this episode, we always ask our guests on this show the same question. And that is, if we gave you the transformation in trials magic wand, and this wand has the power to change one thing in the life sciences industry, what would you wish for?
Wow, I think it would be that more diverse population.
Ooh, yeah.
I think that having that diverse population would have a profound effect on science.
That's an amazing wish, and also ties everything together, because it does start with the design of our facilities. Right. And often life sciences starts in the lab. So how we build the product, that's how the product is until we also commercialize it.
Yeah, and I think that diversity drives down into like higher education and K-12, and making sure that that diversity is brought all the way up through the system and into the laboratory.
Yeah, I love that. It's a great wish.
Sure.
Well, Merilee, if our guests have follow-up questions and want to learn more about lab design, or have any specific questions for you, where can they find you?
They can find me at mlloyd@hed.design. I'm at company is called HED, and you can find us online and on LinkedIn. Just look me up. I'm always there.
Me too. Well, Merilee, this was an awesome conversation. Thank you so much for coming on the show.
I'm happy to be here. Thanks so much.
You're listening to Transformation in Trials. If you have a suggestion for a guest for our show, reach out to Sam Parnell or Ivana Rosendahl on LinkedIn. You can find more episodes on Apple Podcasts, Spotify, Google Podcasts, or in any other player. Remember to subscribe and get the episodes hot off the editor.